Review for the Chapter 3 test. Now, all the tests in this class are exactly the same format. So the format is first you have 20 multiple choice questions. Out of the 20 multiple choice questions, and you don't have to write this down, I'm just going over this again, 15 of them are, they're kind of like conceptual. They're also problems. And you'll see a lot more as far as like diagrams. Now, when I make up the test, I actually get these questions from the New York State Regents. So if you want to do practice multiple choice questions like this, you can Google online like New York State Regents, and they actually have websites. I might have one on Edline where they actually separate them according to the topic. Okay? So you might want to do that again for extra practice. The other 5 multiple choice questions are the reading paragraphs. And these questions are worth, these are all worth 4 points each, which is 80% of the test. Then you have 2 FRQs, which are worth 10 points each. You can get partial credit. Now for this test, what did we learn? Well, first we learned about vectors. And we learned about vector addition and that we have to add vectors head to tail. Then we learned something called vector resolution, where you can take any vector like this, and you can find its horizontal and vertical components which act perpendicular to one another. And, no matter how the vector looks, you can always find the horizontal and vertical components regardless of the configuration. So again, from where you start to where you end up. Then we did projectile motion. So we did 2 types of problems. We did problems like this, and then we did problems at an angle like this. Okay? So we use our same equations from Chapter 2, but when we're doing projectile motion, we're applying the equations either horizontally and vertically. Okay? All right, so what we're going to do now is we're going to go over the multiple choice part of the review sheet. So let's start with question number 1. Question number 1 says the diagram at right represents 2 concurrent forces acting on a point. Which vector best represents their resultant? So when we add numbers algebraically, we get something called a sum. When we add vectors, we have to add them vectorially, and we get something called a resultant. So if you look at the picture of these 2 vectors here, this picture shows that these 2 are tail to tail. Okay? But if I want to find the resultant, I have to add them head to tail. So I can either just leave this one on top alone, and then from the head of this one, I put the tail of the other. And then from where I start to where I end up, I get my resultant. And that's what my resultant looked like. So the choice would be D. Now, does it matter if I do it the other way? No. What if I drew the other one first, this one, and then from the head of that one, I did the tail of the other, and then from where I start to where I end up, I get the resultant. Does it look exactly the same? Sure it does. Okay, so A plus B, B plus A, I get the same thing. Okay? All right, number 2. It says, if a woman runs 100 meters north and then 70 meters south, her total displacement. So I'm going to draw a picture. So this, let's say, is 100 north. From the head of this vector, I'm going to do the tail of the other. I'm just going to kind of do it side by side. That would be 70 south. And then my resultant is from where I start to where I end up, which would be right there, which would be 30. Because 100 minus 70 would be 30. And then you see how it's pointing up, so that's why it's 30 meters north. So this was D. This is A. Now the thing is, you don't just look at the answers on Edline. You physically do this yourself, because then that's going to help you to remember when you have very similar questions on the test. All right, number 3, a person walks 5 kilometers north. So I'm going to draw my little picture, 5 kilometers north. And again, it's not to scale. And then 5 kilometers east. So from the head of this vector, I do the tail of the other. His displacement is closest to, so this is where I start, and this is where I end up. So this is the displacement. Now remember, you need to know the difference between distance and displacement. Distance is when you add it all up. So for this problem, the distance would be 5 plus 5 is 10, and the displacement is going to be the hypotenuse of this right triangle, and you would use the Pythagorean theorem. 5 squared plus 5 squared square root ends up being the square root of 50, which is a little bit more than 7. And then you have to do the direction, and from where I start to where I end up, and then I'll have the angle, but that's northeast. It's a isosceles triangle, so it would be 45. All right, next one. The diagram below shows a person exerting a 300 Newton force on the handle of a shovel that makes an angle of 60 degrees with the ground. The component of the 300 Newton force that acts perpendicular to the ground. So this is the key right here. Perpendicular to the ground. Here's the ground. So perpendicular to the ground is this way. So now on my diagram, this is like my resultant. So I'm going to do my component. So this is going to go down like this. This is going to be the y component, and this is going to be the x component. So they said the component that acts perpendicular, that's the y component. So the y component is opposite the angle. So opposite is sine. So I know that sine of theta is equal to opposite over hypotenuse. So now when I work that out, I can multiply this hypotenuse times the sine of theta is equal to opposite. So the hypotenuse is 300 times the sine of 60 degrees is equal to opposite, which is the y component, because the y component is perpendicular. So then I take out my calculator. And these are the ones you're going to be using on the test. The calculator's dirty. So I press on the calculator 60 sine, and it says 0.866 times 300 equals, and then it says 259, which would be 260. And that is choice B. Number 5 says which quantity has both magnitude and direction. So that's a vector quantity, because that's the definition of a vector. Mass doesn't have a direction. Time doesn't have a direction. Distance doesn't, but velocity does. All right, now we're going to do number 6. Okay, so number 6 said a rock is thrown horizontally. So it's this type of projectile from the top of a cliff at 12 meters per second. So this is equal to 12. Approximately how long, so we want to find the time, does it take the rock to fall 45 meters? So that means that this y is equal to 45. So when we do these problems, we always write our x and y givens. And our x and y given, we're always going to say ax is 0 and g is equal to negative 9.8. Then we're going to say that we're going to take the initial velocity and break it up into horizontal and vertical components. Now this initial velocity is all horizontal. It has no vertical component. So VIX is equal to 12, and VIY is equal to 0. Then we're going to see, is there anything else that we need to know in the problem? And we're going to see, yes, we know this, y is negative 45. So we see that we have three things here. Once we have three things, we can find a fourth. We have G, we have VIY, we have Y, and we want to find T. So now we're going to say which equation has those four variables. So the equation is Y is equal to VIYT plus 1/2 GT squared. VIY is 0, so that disappears. So it just becomes Y is 1/2 GT squared. So now I'm going to rearrange the equation to solve for the unknown in terms of the known. So I'm going to multiply both sides by 2, divide both sides by G, and then take the square root of both sides, and that gives me T. So now I'm going to substitute in 2 times negative 45 divided by negative 9.8 meters per second squared. And then when I do that on my calculator, it comes out to be 3 seconds. So that's choice C. Okay, it says a red ball and a green ball are simultaneously thrown horizontally from the same height. The red ball has an initial speed of 40 meters per second, and the green ball has an initial speed of 20 meters per second. Compared to the time it takes the ball to reach the ground, so now we want to find the time it takes to reach the ground. So if we look at the equation that we just did in the last problem, it's time is equal to 2y over g, right? Where is the initial velocity in this equation? Nowhere. Because the initial velocity, the time it takes to hit the ground is only dependent upon how high it is. It doesn't matter if I drop something or I throw it initially like this. What's going to happen is it's going to hit the ground at the same time. And we see that by looking at our equation. So it doesn't matter if I drop it or I throw it. The only thing that's going to determine how long it takes to hit the ground is how high up it is. So the answer to number 7 is A. Okay, number 8. It says an object is thrown into the air and follows the path shown. Which vector best represents the acceleration at point A? Well, the acceleration due to gravity always pulls down. So it doesn't matter if it's here, 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 here. The acceleration, G, is always down, no matter what. So it doesn't even matter if this is a projectile. If I throw something up, whether it's going up or coming down, gravity always pulls down. Okay, number 9. The diagram below shows a baseball being hit with the bat. Angle theta represents the angle between the horizontal and the ball's initial direction. Which value of theta would result in the ball traveling the longest horizontal distance? So 45 degrees is the longest horizontal distance no matter what. And then we know that the other angles, like the ones that are complementary of each other, so like 30 and 60, and ones that add up to 90, they would go at the same angle. But it's always going to go the farthest at 45 degrees. All right, let's go to the next page, to number 10. So number 10 says an archer uses a bow to fire 2 similar arrows with the same force. One arrow is fired at 60 degrees with the horizontal, the other one at 45. Compared to the arrow. Now, we know that the 45-degree one is going to go the farthest. So that's, remember, the word range means how far it goes horizontally. And then when it says the shorter time in the air. Now, you could actually calculate this. A lot of people just memorize this, but if you wanted to prove it mathematically, you could have your two scenarios. You could have my 45 degrees, and then I could do my 60 degrees, and I could say, well, let me compare. So I know that, and you don't, by the time you take the test, this isn't something you would work out. This is just something you would know from doing other problems. So AX is 0, G is equal to negative 9.8. If I wanted to find the horizontal and vertical components of these, again, VIX is equal to 0.707 VI, VIY is 0.707 VI, and I know that Y is 0. Once I have these three things, if I wanted to find time, I could use the other equation, Y is equal to 1/2 GT squared, and then if I wanted to find the horizontal displacement, X is equal to VIX times T. So if I was to work all these out for each of the angles, I would know that I could just compare these and know that, again, that there's the shorter flight time and the longer horizontal range. And again, by comparing let's say because X is equal to VIX times T, I could just look at, like for the 45 degree one, VIX is equal to 0.5 VI, and VIY is equal to 0.866 VI. All right, for number 11, this one, I would just do it the same way I do everything else. So this is the one where the initial velocity is like this, VI, and it's going to go like this. And it says the diagram below shows a cannon. This is 50 meters. When the cannon is fired, it leaves with a horizontal speed of 250. So now it says, which action would most likely increase the time? So now we want to increase the time. So this actually goes back to the same equation where if we're looking at it, if I wrote out my equation, Y is equal to V naught YT plus 1/2 GT squared, and this is 0. So Y is equal to 1/2 GT squared. So now they're saying, how are you going to increase the time? Well, time is equal to the square root of 2Y over G. Does G ever change? No. So if I want this time to increase, the only thing that I can increase is what? Y. So G is a constant. The only way to increase my time is to increase Y. So now I'm going to look at my choices, and it says positioning the cannon higher above the ground, because that's the only thing that's going to increase Y. Now everyone does these. There were already a couple of problems like this that we see that the only thing when a cannon is launched horizontally that's going to affect the time is going to be the height above the ground. So maybe at this point you already know that, and you don't have to work it out. But for me, a lot of times, if I'm not sure, I like to prove things mathematically. And then once I see it mathematically, I'm like, yeah. All right, number 12. A ball is thrown horizontally at a speed of 20 meters per second from the top of a cliff. How long does it take the ball to fall 19.6 meters? So again, this is the same problem. It goes like this. So if I do my x and y given, AX is 0, G is negative 9.8, VIX is 20, VIY is 0, and Y is equal to 19.6. So this is the same equation we did before. Y is equal to VIYT plus 1/2 GT squared. This is 0. So Y is equal to 1/2 GT squared. I rearranged this. I've already done it on this review sheet like 5 times. The square root of 2Y over G. So T is equal to the square root of 2 times 19.6 over 9.8. So then when I do that on my calculator, 2 times 19.6 equals, divided by 9.8 equals, and then square root ends up being 2 seconds. And that is choice B.
Why isn't it a negative? Oh wait, because they're both negative.
19.6 is negative, and this is negative, and the negative in the numerator and the denominator cancel, so then we don't have a negative under the radical, because that wouldn't make sense. All right, number 13, it says a projectile is launched at an angle of 53 degrees to the horizontal with a speed of 80. What is the vertical component? So here's my vector here. This v is equal to 80. And I know that my horizontal and vertical components look like this, VIX and VIY. And this angle here is 53. And it says, what's the vertical? So the vertical is VIY. So VIY is opposite, which is sine. So it's going to be 80 times the sine of 53 degrees. So I say 53 sine times 80. And that comes out to be 64. Which would be choice C. Number 14, a projectile is fired at 150. What's the vertical? So this is asking me the same thing. So for number 14, this is 150. This is VIX. This is VIY. And this is 30 degrees, so VIY is equal to 150 times the sine of 30. So now on my calculator, I press 30 sine times 150 equals 75. So this is 75, which is choice A. And then the last question says, which is a vector quantity? And it's just like that other one, an easy one, and the answer is displacement. So this is the review sheet. Again, you should still do this again on your own. This is the multiple choice part, and then we'll work out some of the other ones on the FRQs as well.